Okay, so this is the final video of the year. All right, so I'm going to just do a quick video here, and you should take some notes and turn them in, but we'll try to keep it fairly straightforward and simple. Okay, I want to know how a projector works. Right? So ultimately, for a projector, we want to cast a large image on a wall that's pretty far away. So we start with something that's a really small image or some really bright screen inside of the projector. It takes a really strong bulb to make that image be able to spread out on a wall that's far away, because the image could literally, let's just say, actually, if we start with an object that's maybe 2 centimeters by 2 centimeters, that's 4 square centimeters. All right. On the wall, the final image might measure 2 meters by 2 meters. If we want to have, it's probably not a good movie ratio. That'd be a square. But what we have up on the wall might be something more like 4 meters squared. Okay. Now, 4 meters squared, if you were to convert that, it's going to be 10 to the second centimeters per meter, and then you square that if you want this in square centimeters. So you end up with 4 times 10 to the 4th square centimeters. So we've amplified this by a factor of 10,000. So you need to start with a very, very bright object so that if you spread it out over an area that's 10,000 times larger, it's still bright enough to see. All right, so movie projectors have an extremely strong bulb in them in order to be able to make this happen. So if I want to do that, okay, I'm going to actually use 2 lenses. And the focal point of the first lens, I'm just going to draw it as a flat line. It's going to be a convex lens. Is going to be very close to the original image. I'm sorry, the original object. That's an object. Okay, so let me start drawing some rays in. Okay, so these are the focal points. I'll make those larger. So primary ray 1 comes out like this. Primary ray 2 goes down through that focal point, hits the lens, and then comes out parallel. So right here is the intersection of those rays. If we were to, there are an infinite number of rays, remember, coming off of there. And so we could trace them all, but we're just tracing those 2 primary rays. That's good enough. We won't even put the 3rd ray in this time. So we will get an image from lens 1. Okay. That image is a real image. Those light rays really come together there. It's inverted, and it's a lot larger than the original image that I had. Okay. Now this image from lens 1 is going to become the object of lens 2. Okay? So that's an important idea. The image from lens 1 becomes the object of lens 2. And we're going to have a similar thing happen for lens 2. We're going to have the image, the focal point of the second lens is just going to be a little bit in front of where the object, where the intermediate image is. Okay, so let me put in another lens. I'll put it right here, and we'll put a focal point there and there roughly. Okay, so actually I'm going to move those focal points over a little bit. I'm going to put it there and here. Okay, so if I use those closer focal points, there's primary ray 2. Okay, you can see it would go all the way up there. My lens would need to be bigger and then go out parallel. And primary ray 1 would do something like this. Okay, and here's where they really meet. So this gives us an even larger image. Now, a couple of key things. It's once again, it's real. The light rays will really meet there. And the image is going to be upright and larger once again. Okay, I think I actually curved that first line down a little bit too much. So this image would probably be significantly larger and farther back if I hadn't curved those rays a little bit in drawing them. But the key is if I were to slide this lens in even closer to where that first image is, I would get an even larger image that would be further back, that would be further off to the right, where everything would meet up. So the closer I put that focal point to the intermediate image, the larger the final image will be. And likewise, the closer I move that first focal point, or maybe I move this lens over towards the object or the object towards the lens, the closer I make that, the larger the intermediate image will be. So I'll have a couple of multiplying factors that allow me to cast a very, very large image on a screen that's quite far away.